This is year 10 notes. We're in unit 5 and we're looking at then the gradient of a line and just doing a wee example from it there. So gradient of a line people tend to find quite complicated, but effectively it's the steepness of the line. So if you look at these two lines here, line A is a steeper line than line B, and so it then is going to have a higher gradient. It's going to have a higher number then attached to it. One definition of a gradient is a difference in the y coordinates and difference in the x coordinates. Some people then call that as well rise over run. So we're going to do it that way as well, and then I'll give you a third method as well to work it out in terms of these three that we have to do here. So I'm going to call this one line 1. I'm going to call this one here, let's go for line 2 over here, and then line 3 down here. We're going to find then the gradient of each of these. So difference in y coordinates, difference in x coordinates is effectively you want to pick a couple of points then on this line. So let's check that we can just see that there as well. So I'm just going to pick this one here, and I'm going to pick this one here, I guess just at random. So that's the point -3, 1. And that is the point 1, 5. And so for line number 1, our gradient, the difference in the y coordinates, so the y coordinate here is 5, and then the y coordinate here is 1, so 5 take away 1 is going to give me 4, and then the x coordinates 1 and -3, so it's 1 take away -3, so it's 1 minus -3, so that's going to be 4 as well, and that gives us then a gradient of 1. The other way of doing this is to do your rise over run, and that's effectively you make it into a right angle triangle and you count the squares. So how far, this is called the rise here, how high does it go up? It goes up 4, and this one goes across 4. It's very similar obviously to our coordinates, it's the same idea. 4 divided by 4 then is going to give us 1. The other way that you can do it is the gradient tells you how many squares you go up for every one that you go across. So across 1, up 1, across 1, up 1, across 1, up 1. So every time we go across one square, that's always one square, the gradient tells you how many then you're going up, so the gradient in this case then be 1. Number 2, I'm obviously going to pick this point here and this point here. There's very little else you can pick that actually kind of goes through an actual coordinate. So our gradient then in this case, the difference in the y coordinates, so I need to put a coordinates in, so that's the point 4, 3, and then that is the point 3 minus 5. So the difference in the y coordinates, 3 and -5, there are the y coordinates, so 3 minus -5, that's going to give me 8, and then the x coordinates are 4 and 3, so 4 take away 3 then is 1, so 8 divided by 1 then just gives us 8. In terms of doing rise over run, it's a very steep one, this obviously, that's why the gradient then is going to be a lot higher. That's why we've got 8 here and we have 1 here. You can see this one's an awful lot more steep than the other one. And so my rise, how many squares? 1, 2, 3, 4, 5, 6, 7, 8 obviously, and 1 across, so 8 divided by 1. And finally the gradient tells you how many squares you go up for every one that you go across. So you're going across 1, and that's up 8. Hopefully you can see that there at the bottom. I'm worried we're kind of off the screen, but that's where they are. In case you can't quite see that, apologies. Finally then line 3, this one's going the other way, so it's going to be a negative. Let's just pick a couple of points on it. So I'm going to pick this point here and this point here. We'll just kind of pick the two end points and see what we have. So what's this point? This is the point -5 minus 1. And then this is the point 1 minus 4. So as long as we're consistent here, we're going to be okay. So the difference in the y coordinates, let's go for this one, take away this one. So it's -4 minus 1. So that's -4 plus 1, so that's then going to be -3. And then the x coordinates is going to be 1. And because I took the -4 first, I have to take this one first. 1 minus -5. And that then is going to give us 6. That cancelled down then and gives us minus a half. Rise over run method for that, again, should work. This one you maybe just kind of want to be able to see. You can see this one's going the other way, so it is going to be a negative anyway. That's a 3, 1, 2, 3 squares, and that's going to be 6, so that's 6 squares, so you can see then how that's going to work out. The final method I sometimes think is the easiest if you can work out what's going on. It tells you how many squares you go up for every one that you go across. So if we start here, if we go across 1, we're actually going up minus a half. You see that? Because if we're going across 2 down 1, so we're going down half a square each time. So every time we go across 1, we're going up minus a half or down a half. That's where our gradient then is going to be minus a half. On to the next page then, where we're going to draw one out. It's just another line that we're dealing with. So compare the table and use it to draw the graph of y equals 1.5x. Minus 4, subbing in then for x, 1.5 times minus 4. It's going to give you minus 6, 0 gives me 0, and 2 1.5s then are 3. So plotting these on again, I've done my axes already here, just to save a little bit of time in the video, so hopefully you see what's going on. Point minus 4 minus 6 is here, so there's minus 4 minus 6, 0 0 is our point, and then 2 3 was our other one, 2 across, 3 up. Again, as you know, I have forgotten my ruler. So let me draw this on here and extend the line on up. See through there, I think. That's not bad. So it's going to be a straight line. As I said, then the name of this line is y equals 1.5x. Let's see what the question says. Choose your own pair of points to find the gradient of this line. How does the value of the gradient compare with the equation of the line? So let's pick some points here. There's a point there I see is definitely on the line. That is the point minus 2 minus 3. We can't pick that one because that was one of our line points. And then there's a point 4 6. Okay, so our gradient then is the difference in the y coordinates. 6 minus minus 3 is going to give me 9. And then 4 minus minus 2. And if I cancel that down, then I get 1.5. Or I'm going to write it then as 1.5. So I guess what we want you to spot is that the 1.5x here is the same then as the gradient. The number multiplied by x in any straight line graph tells you the gradient of that line.